So for post-quiz tutorial number 2, I did problem 4.p.81, and this is basically a problem that asks like if a hole were drilled through the earth, like perfect with the diameter, how long would it take for the like mass that is mass m to reach the other side? So what you're given is that the distance from the center of the earth to the mass is r, little r. And then, of course, you have the radius of the actual radius of the earth. So you're given that the gravitational force of the mass to the, like on the earth, from the earth or whatever, is mg times little r over r, which is the only force acting on the mass. So I applied the momentum principle, which of course states that force is equal to the change of momentum. So I said that force is equal to, which this is the force, and I made it negative because it's gravitational force going in this direction. So force is equal to mass times velocity, and so mass times dv dt is the change in velocity. So I made d dt times dr dt. R is the distance from the center of the earth to the mass, so I made that basically the resting position of the mass. So it would basically be like x is its position, but I'm making it r instead because it was named r. So when you put this together, and you can actually cancel out the m's, so you end up with negative g times r over r equals d squared r over dt squared. And when you combine this actually looks like the equation for the motion for an oscillating mass spring system, which is what I'm comparing this problem to. So the equation for that is d squared r over dt squared plus k over mr equals 0, where omega equals the square root of k over m. So since these were similar, I basically I treated this as like m will oscillate through the earth with the angular frequency of like omega equals the square root of g over r. So in order to find the time that it would take for the the mass to move like through the earth to the other side, it's going to be half of the period. So using omega, I'm going to find the time, and then I'm going to half that to actually find the time that it would take to go through the hole. So omega equals 2 pi over t. Rearrange that, so t equals 2 pi over omega, and then plugging in, that equals 2 pi times the square root of r over g. And so half that again, like I said, and that's going to be pi times the square root of r over g. And we know that r, which is the radius of the earth, is 6.4 times 10 to the 6th, and g, of course, is 9.8. So your final, the final equation is going to be pi times the square root of 6.4 times 10 to the 6th divided by 9.8, which equals 2,538 seconds.